Hello everybody, welcome to this new chapter. Now we are in this chapter we are going to see the various aspects of OBD in the emission perspective. All right. So first let's discuss the 2010 OBD standards and how they improve emission monitoring for heavy duty engines. So by default heavy duty engines will be diesel engines. How did the 2010 OBD standards improve emission monitoring for heavy duty engines? The 2010 OBD standards brought substantial improvements to emission monitoring for heavy-duty engines by introducing comprehensive real-time diagnostic capabilities and stricter regulatory thresholds. Okay, so this is a major observation by every industry expert. Introduction of 2010 OBD standards, it improved the emission monitoring to a next level by and how did it do it? It introduced a comprehensive real-time diagnostic capability, stricter regulatory thresholds. All right, and comprehensive component and system monitoring. The 2010 standards required OBD systems to continuously monitoring virtually every emission related component and system, including exhaust gas recirculation. Understand this carefully. It is monitoring exhaust gas recirculation, DPF diesel particulate filters, selective catalytic reduction SCR, oxygen sensors, and electronic fuel injection systems. So all these things were under the vigilance uh, or the monitoring of the OBD system. And these systems must detect or they will detect malfunctions and deterioration before emissions exceed prescribed thresholds, ensuring early identification and correction of issues that could lead to excess pollution. So naturally, as the vehicle becomes older, engine becomes older due to wear and tear, there is a good chance or high probability that emissions increase. So these OBDs, they keep a proactive eye or a clear bird's eye view on the deterioration of the emissions and deterioration of the components so that the owner can proactively take necessary action to ensure emissions are well within the limits. Now, second is stricter emission thresholds and early fault detection. The emission standards set a much lower limit for oxides of nitrogen, which is zero point 0.2 gram per bhp hour, which is 90% reduction in previous standards. And OBD systems are designed to activate the malfunction indicator light and store diagnostic trouble codes when emission control systems fail or emissions approach this tighter thresholds, prompting timely repairs. And also, the standards require threshold monitoring for with key pollutants, which is of course NOx, particulate matter, hydrocarbons, and carbon monoxide with malfunction indicator lamp or light activating progressively closer to actual emission limits, reducing the likelihood of high emitting vehicles operating undetected. Okay, so with the help of mill, the OBD clearly conveys to the driver that there is a likelihood of vehicle emitting higher pollutions. Okay, now coming to the standardization and data access. The 2010 OBD regulations established standardized diagnostic protocols and connectors, enabling consistent access to live, historic, and drive cycle data for service providers and regulators. This standardization supports efficient vehicle serving, regulatory oversight, and data-driven emissions compliance. Okay, so this standardization is extremely important. And next comes the phased and expanding coverage. The implementation began with highest volume engine families in 2010. So it started with high volume engine families, high capacity engine families requiring full OBD certification and liability for emission thresholds and expanded to all heavy duty engines by 2016, ensuring broad coverage and accountability across the industry. So it started with some big engines, maybe like 9-liter engine or 18-liter engine, and slowly it started expanding to diesel engines like truck engines, which can be 1 liter, 2-liter engine or 3-liter engine also, and across the entire industry. And these standards also require monitoring of both threshold and non-threshold aspects of emission control system, covering 75 to 100 signals per engine. Now, real world effectiveness, the OBD systems are required to function throughout the operational life of the engine, not just during warranty periods, ensuring long-term emission compliance. The use of advanced sensor and onboard data collection enables real-time in-use emission monitoring, which is vital for meeting ever lower regulatory limits for future regulatory programs. Okay, so in the real world, this usage of advanced sensor, it enables a proactive in emissions monitoring, which is vital for meeting ever lower regulatory limits. Now, as you know, as the time is progressing, the regulatory bodies are imposing more and more stringent emission limits. So this requires more efficient onboard diagnostics and more onboard monitoring, which is fulfilled by the modern onboard diagnostics in the market. Now, what are the main key improvements from 2010 HD OBD standards? We will have a small summary. First is component monitoring, continuous comprehensive coverage of all emission related systems, fault detection, early warning via MIL DTC closer to actual emission limits, emission thresholds much lower NOx PM limits with OBD triggering before the limits are exceeded. Okay, especially NOx and particulate matter, which are very important pollutants as far as heavy duty diesel engines are concerned. Of course, HC and CO are always within the limits because diesel engine or compression ignition means automatically it's a lean mixture. Now, coming to the standardization, universal protocols and connectors for diagnostics and data access. Now, coming to the coverage, phased in for heavy duty engines with both threshold and non-threshold monitoring. Real world monitoring sensors and systems designed for accurate, durable in-use emissions tracking. All right. Now, so finally, in summary, this 2010 OBD standards transformed emission monitoring for heavy duty engines by mandating, this word is extremely important. It mandated continuous comprehensive standardized diagnostics, and this ensures early detection of emission control failures, prompt repairs. Okay, as soon as there is emission control failure, prompt repair is enabled by OBD standard and sustained compliance with much stricter emission limits, resulting in cleaner air and improved public health. Okay, so I hope all of you understood what in how many multiple ways this heavy duty OBD standards have aided in controlling the emissions. Thank you.